Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast. Dependency Injection, making a turducken out of your code.
Dependency injection removes the need to create instances of services within your code. Instead of having a module of code call the other modules it may need to function, dependency injection passes those into it from the original caller. Now, this is usually a framework or other higher level code sitting on top of the custom code that you write for controlling the flow of your application. In this episode, we're going to be talking about how dependency injection works, its various parts, and the different ways that it's implemented. And we're going to finish up discussing some advantages and disadvantages of using a dependency injection framework. This episode came from a listener's email requesting more information about the topic, and we're going to read that email in just a moment before we get started. Will, what have you been fighting this week?
Man, I've had so much on my plate, it's not even funny, right? Like the book has a very aggressive editorial calendar attached to that. And so I wrote 36 pages of content this last weekend and net. And it's probably closer to 50, including the stuff I edited, which takes a long time, right? Like that's a lot of stuff. So that has been a lot. We're also trying to get a release out at work, any day now. In addition to that, upper management was gone for a good part of the week this week. Like there was 1 or 2 days in there where I was the closest thing to a manager in the building.
Wow.
Yeah. And so you can imagine how that particular circus works. No, actually, like none of those people really need management. Like you don't have to really do a whole lot. You just got to make sure things are okay. But it's just been a lot, man. I get up, I plan my day out. I take my daughter to school. I work all day. I come home and I work again, and then I go to sleep. Like I hadn't played any video games in like at least a month. The only thing is I'm reading a book, at night, right as I go to sleep. Like that's the only playtime I'm having right now. Yeah, it's crazy. So how about you?
Well, I haven't been playing much video games, though I did get Splatoon 2. So it's like a shooter game. It's not first person. It's kind of like a third person shooter game, but you're shooting paint. It's a Nintendo game, so it's more kid friendly and kind of thing. But it's really cool because your character can go between, I call them inklings and squids, which when they're not swimming around in ink, they actually do look like little squids. But you have to like turn into a squid and swim around in ink to refill. It's really neat. It's got a huge online component, but it also has a just play by yourself kind of thing too. So I got that last week. Been kind of playing with it a little bit. I don't get a lot of time to play video games either, so I understand, man. Dude, .NET Core. Oh my goodness.
Buddy.
Yeah. I am building this console app. They don't exactly have a template for what I'm doing. The good news is I'm learning a lot about how the integrated dependency injection framework works with .NET Core, and a lot about how just the various components fit together and how to do things in it. A lot of setup involved, a lot more than normal .NET development. But the whole point is you do that setup once, and then the rest of your development is pretty straightforward. The problem is the rest of the development is just this really simple console app that's taking files from one place, making sure they fit the right format, and then putting them in another place.
Yeah, it's almost like Core is hard for those kind of apps. Like it does too much. Mm-hmm. The other thing I've encountered with it is I really hate when I get a framework or any kind of setup like that where I have to make all the big decisions up front and implement all the stuff up front. And I feel like, because my thing is I start a new project, and after a week, management wants to see what I've gotten done. And if I go, I wired up all this abstract code stuff, like they don't care. Yeah. They do not care. And core doesn't feel like it's there yet as far as making it where I can be productive quickly and show a week's worth of work when I've worked a week.
Yeah, well, the thing is, if I were doing like an ASP.NET Core app, it would have been fine because I've got templates for that. And, just the basic setup is kind of already there. I don't think it was in 1, but in 2, it's pretty straightforward. I've built some learning that were pretty easy to get set up. And then as I added stuff to it, I went back and I had to add it up at the startup level. I mean, one of the things I really like about it is using the DI framework. You don't have to, you just say, all right, add this to the service. And it goes, all right, if one exists, especially if it's a singleton, if one exists, it grabs it and adds it. If not, it creates it.
Yeah.
And if that requires stuff, so you don't have to I don't have to tell it, oh yeah, when you create this, I need you to pass in all these things. It just looks at it. It looks at the constructor and goes, oh, you need all these other things. All right, if one of those exists, I'll pass it in. If not, I'll create it. So it does all that work for you.
Yeah, it is nice once it's running.
Yeah, right. Once it's running, it's really great. My problem is right now I'm trying to deal with multi-threading in there, and it's a bit of a headache. But
yeah.
Also, we're updating our servers at work, which requires updating some of our older apps. So when I'm not working on this console app, I'm working on some of the older stuff. I've been deep in legacy code, making updates between, the fixes in the code that's about to go to production, working on this .NET Core app, and then dealing with legacy code. It's been sort of the last couple of weeks have been interesting. I've been learning a whole lot. I'll be honest, though, it wasn't easy figuring out how to make updates to the legacy code to work with the new TLS requirements.
So, yeah.
That's interesting. But you know what? Speaking of security, I've got an article about security in IoT for IoTs. This is an article by Kaushik Paul, a technical architect and software consultant. And it's about security in the IoT realm. Our world is becoming increasingly more connected. Just about anything that you can own can become a smart device. We have smart homes, running multiple devices, and even smart cities these days. In the article, Kaushik addresses some of the concerns with having so much connected to the internet. He talks about issues such as unsecured networks, weak interfaces, encryptions, out-of-date updates, and a whole lot more. For each one, he explains the issue and then provides a potential solution to working within the IoT realm. It's really cool. It kind of reminds me of a lot of the times that we talk about problems in a certain area. Like this article looked a lot like some of our show notes, really. It was really cool reading through it. And I'll have a link to that in the show notes. Will, who's talking to us this week?
Well, we got an email from Scott Blaylock saying, while the comment may sound negative, it's really not intended to be. I really like your show and find value in it. I need to learn DI, and I listened to your DI podcast, but after you gave the basic theory, a different podcast broke out. I'm unsure if you misspliced or if the podcast was over and I was listening to a different podcast, but I found myself listening to a podcast concerning OS process scheduling and resource management and wondering, was DI related to OS scheduling? I'm confused. Anyways, I would love to hear about DI beyond just passing the resource into the object and why we decouple. How about the details about the creation of the objects by the DI container and details about which ones you use and why, and issues you found with the others, basic setup, how to integrate it into unit tests, etc. The architecture of OSs is very interesting, and I love to hear about that, but I was looking for DI at that moment. Cheers, M. Scott Blaylock.
Scott, thank you for the feedback. We like hearing about the ways that we can improve the show. Sorry for the confusion. We'll have to work on our transitions to explain things better and maybe our intros to talk about what's going on with the episode.
Yeah, so the episode in question was about inversion of control, and dependency injection is one way to apply the principle. The goal was to give a high-level overview of some different ways that inversion of control is applied. And it gets confusing when you have the dependency inversion principle, which is different from DI and inversion of control. It's the overarching principle that they both fall under. So DI implements inversion of control, which implements dependency inversion principle. It's kind of a turtles all the way down thing. And what we gather from your comment is that you would like to hear a deep dive into DI.
So, Scott, you are in luck. We built this episode as somewhat of a response to your email. I don't know that we're going to cover all of the things that you requested because some of those get into the specifics of the framework that you're using or the language that you're using. So we're not going to go into those kind of specifics, but we're going to go into a better understanding of dependency injection. Send us another email with your contact information because we've got a complete developer water bottle just for you. And guys, if you'd like your very own complete developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all of our episodes to Facebook, Twitter, LinkedIn, and for the time being, Google+. We're also on Instagram and Tumblr. You can check us out each week on Facebook and Twitter and YouTube Live. We talk about what's going on in the tech world and answer some listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
This episode is brought to you by Clubhouse.io.
Clubhouse is the first project management platform for software development that brings everyone together so that teams can focus on what matters, creating products their customers love.
Clubhouse provides the perfect balance of simplicity and structure for better cross-functional collaboration.
Easy for people on any team to focus in on their work on a specific task or project, while also being able to zoom out to see how that work is contributing towards the bigger picture.
With a simple API and robust set of integrations, Clubhouse also seamlessly integrates with the tools you use every day, getting out of your way so that you can deliver quality software on time.
As listeners of Complete Developer Podcast, you guys can sign up for 2 free months of Clubhouse by visiting clubhouse.io/completedeveloper.
Dependency injection, or DI, is an implementation of the dependency inversion principle. And we're not going to get into the turtles all the way down thing again. But the principle itself states that high-level modules should not be dependent on lower-level modules, but instead both should be dependent on abstractions. Also, abstractions should not depend on details. The details should depend on the abstraction. The high-level modules should be independent of the implementation details of the lower levels. The low-level modules should be designed with the interaction in mind, as it may need to change interfaces. However, the inversion of dependency does not mean that lower-level layers depend on higher-level layers. Both should depend on the abstract interface between them. This reduces coupling of components without adding more code or coding patterns.
So as dependency injection has 3 main responsibilities, the most important of which is creation of objects. The next is knowing which classes require those objects that it creates. And finally, it provides the classes all the necessary objects to function. The goal of dependency injection is to separate the usage of an object from its creation. And this removes a class's direct dependency on another class. Dependent classes can be changed without the dependent class knowing or caring. So, if Will needs something that I can do, he needs me to edit audio. While using dependency injection, he just needs someone to edit audio. It doesn't have to be me.
Right. And that's really where we actually need to go. That's, it's really a fundamental premise of business, that's gotten crammed back into everything else. So in this episode, we'll be talking about the different roles within a dependency injection framework, how dependency injection works, the different types of dependency injection, and finally, some advantages and disadvantages to using a DI framework.
So starting off, the roles in dependency injection. Now, there are 4 basic roles: the service, the client, interfaces, and the injector. The service is the object that is depended upon in order for the module of code to work.
Yeah, and this can be any object or class that is used by another object or class. So it's not service in the sense that you think of as service. It's just like, here's a doodad that you're using, whatever it happens to be.
I prefer baubles to doodads personally. This is the object that we want to decouple from the calling object or class. So it's the thing that is doing some function, some work. It's the editor who's editing the audio that we want to decouple from Will, saying, I need this audio edited.
Right. In other words, you really aren't safely delegating to something when you know too much about what's actually happening.
The client is the module of code being called that is dependent on the service. So this is any object or class that uses another object or class or module of code.
Right. And it shouldn't know anything about the service that it uses. I mean, that's kind of the point. And that is why we got into the whole interface thing, is that keeps it from knowing.
Yeah, interfaces define how the client is able to use and interact with the service.
Yeah, and this should be all that the client sees or knows about the service object. So an interface will define the methods available to the client. This includes what's passed in to each method. Some languages, it'll also include like what kind of exceptions can be surfaced. It doesn't do that in .NET, unfortunately. I wish it did. It also contains what's returned by the method. It can be, lots of other specifiers depending on the language as well. I know, .NET, like an interface will have, if you're doing async, it'll return a task. You don't have the specifier that it's async.
Yeah.
So it's weird. This is a weird spot, but essentially you're defining a plug that you're plugging into, and that's it.
You're basically saying, it's going back to the unexpected audio example. The interface is, here's a segment of audio, or audio is what needs to be edited, and a edited audio is what's returned.
Right. Along with some whining.
Yeah.
It's an exception. Actually, no, it's not really an exception because it doesn't stop the flow, right?
Yeah.
It's in the return envelope. If we're going into interface specification, how this works.
No implementation details, or basically how the service method works, are involved in the interfaces. All it is, like we said, what's being passed in, what's coming out, and a few other details, metadata basically around that.
Right. And that's like in .NET, that's why it returns a task and not an async task. Right. There's nothing saying you're doing this async. There's a thing that's like, here's the thing that you get out of it. We're not going to tell you how we're doing it. Now, interfaces may also be abstract or concrete classes, right? So it doesn't have to be an interface. It can be an abstract base class, including one that's empty, that doesn't have any implementation at all.
Now, making one a concrete class does kind of violate the dependency inversion principle a little bit. Violate a little bit is like being a little bit pregnant. It violates it, let's just say. It removes the dynamic decoupling that allows for unit testing. Yeah,
it does. As long as that class can be extended, the IOC framework will usually let you protect yourself from this. But I'm really careful about ever using a concrete class in this kind of thing, because I know that people will do dumb things if they are able to.
Right. And that's why I want to say, I wanted to be like, all right, if it's something where you have to do that, you can. The thing is, to do this, the client would not ever construct that concrete class. So they wouldn't be treated as concrete, even though they are. And there is a whole rabbit hole of legacy implementations and how to meet the dependency inversion principle that we're not going to go into. And we may make that into a separate episode, because there's a lot of information about how to implement this in legacy applications and how to apply unit testing specifically.
The calling code responsible for constructing the service and injecting it into the client is called the injector. Now, injectors may also construct the client's passing in the dependencies on construction. So these things can be chained, in other words.
And we're going to talk a little bit more about that later.
Yeah, but the long and the short of it is it can connect complex object graphs for you. It's not just a single, like, give me this thing. It's like, give me this thing and by policy, all the crap that it needs to run.
It does this by treating objects as both clients and services. So like a service may be a client if it has its own dependencies. So going back to our thing about Will needing audio edited, he may pass that audio on to me, and then, me as the service then passes it on to another service that I have hired to do that for me, and then it comes back to me and I hand it back to Will.
Yeah.
The other thing to think about, and going back to like .NET, would be if you have, it doesn't have to be .NET, but just sort of a MVC type thing. You have a controller that calls a service. The service recalls a repository, which calls a database back up. So at that repository level, it is both a client and a service.
Yeah.
Now,
and any one of those will have lots of stuff potentially under it.
Now, like Gandalf and me, it goes by many names. Could be the assembler, the container, factory, builder, provider, main. There's a lot of different things that injectors can be called. And also, like concrete classes as interfaces can violate the dependency inversion principle, but still be used in dependency injection, this role is not required by the dependency inversion principle.
Right. This is often not something that you have to build when you're implementing DI anyway. Usually you use somebody else's library because some of the stuff gets really weird around the edges. Like at a framework level, like how do I make this thread safe? How do I make sure stuff really gets destroyed when it's supposed to be? How do I probe and figure out which constructor to call dynamically? Like things get ugly really, really fast, especially with complex object graphs. So don't ever build this stuff on your own unless you just really, really want to do it for academic reasons.
Or you absolutely have to.
Yeah, like it's your new language that you wrote and you're the guy that has to do this. Fine, yeah. But most of your frameworks are going to provide ready-to-use injectors somewhere.
That's one of the things I did like as I was learning the .NET Core stuff is just how well that was done. It's basically you say, all right, from my understanding, there's three types you can have. You can have a singleton, which is one for that session of the app. A scoped. Right,
which goes to like your web request or to a unit of work pattern of some sort. And then you can have transient.
Which is every single, every controller, every service gets its own. And the really cool thing is you tell it to build it. You say, here's the interface and here's the class that implements it. And that's all you do. You tell it what it is and the interface and implementation, and that's it. You don't do anything else. And the framework handles it for you. So when you write something that needs that, you put in the constructor, all right, I need, this interface and call it whatever you want. When it creates that, it goes, oh, hey, I need that. Let me go find an implementation of it. Oh, I've got one already. Let me pass it in. Oh, there's not one. Let me create it. It's just so nice because it does all that work for you. It takes care of, like you were saying, the lifetime and how long they last. So that's one of the benefits of frameworks. And we're going to get more into that when we talk about the advantages and disadvantages later on.
Yeah, just as an aside, have you gotten to play with passing open generics in there yet?
Not yet.
Yeah, I'm wondering how well that works in core, because I know I liked that in structure map. I could say, get implementations for types closing this, and give it some type, and it would automatically figure that stuff out, which is like awful reflection code that I don't want to mess with. It really made my day that was there.
Yeah, I haven't gotten into a lot of that yet, so that's thankfully not the level I'm working at yet.
So let's talk a little bit about how dependency injection works. And what it does is it breaks the dependency between higher and lower level classes through the use of interfaces.
We've kind of hinted at this already in several of the things that we've said.
Yeah, and higher level classes are any class that calls another to use its methods, and these are your client objects.
For example, in ASP.NET, this would be your controllers would be a high level class.
Right, and then your lower level classes are ones that are called by higher level classes. So this might be your service layer, your repository layer, your database connection factory, whatever thing that you've got under the hood. Hi, Java. Right, like if you've got all that stuff going on, those are your lower level classes. And I mean, these are kind of loose classifications, but
the thing about it is any class can be high and or low based on its connection and dependencies on other classes. Like we were saying, it can be both a high level class and a low level class. To what it depends on, it's high level because it's above its dependencies, but to what depends on it, it's low level because it's below that. Implementations of interfaces are passed into the client by the dependency injection framework. We were talking about that a little earlier. the dependencies are created by the injector when calling the dependent code. And when I say created, it may be they already have one. So in .NET Core with the singleton, it creates that once and then passes that in to everything that needs it.
Right. And the client is not allowed to create new or static methods, right? Like you don't want to be putting stuff out there that's not in the interface specification because it's not reachable by anybody else. And statics are especially bad for locking your dependencies in a bad way.
Oh yeah, I'm running into some issues with that. So
yeah, I run into them all day, every day.
About the only time I use statics is for extensions.
Yeah. When stuff is legitimately static, then it's okay.
Mm-hmm.
The client itself doesn't need to know about the injecting code, only the interfaces of the services being injected.
Yeah, it should not have any knowledge of the implementation of its dependencies. It doesn't care. It knows it passes one thing in and it gets another back. That's all the client really cares about. If something in the dependency changes, the client should not have to change because the interface is still the same. What happens behind that interface? I don't care. If going back to our audio example, if I hire a service, and we've been talking about hiring a service to do our audio, that's why it's top of my mind. But if I hire a service and I pay them to do it, I know I give them my audio and I get back a finished product. That's all I care about. I don't care how they do it. I don't care if they use Audacity, Reaper, GarageBand, Adobe Audition. I don't care what they use.
Yeah, I don't care if they're messing with bits directly on the disk platter. It's not my problem.
Right, exactly.
That's the main thing is that it keeps change from creeping further out than it's supposed to. The injector creates the lowest dependency first and then passes it into the next lowest one. This continues until all dependency chains and hierarchies have been created. Then the injector calls the client, passing in those dependencies.
Right. So let's just do a pretty basic CRUD app using a repository pattern. So you have a controller that calls a service. The service calls a repository that talks to the database. So it has your database connections in it. So the DI framework would create the repository and then take that repository and pass it into the service when it creates that. And then it would pass that service with that repository in it to the client or the controller when it creates that. So dependency injection, it's an alternative solution to the service locator pattern. Like dependency injection, the service locator improves modularity and reduces dependencies between classes by using interfaces. So it sounds very similar, right?
But where it differs, and we used to use service locators all the time, but where it differs from dependency injection is in how it gets an implementation of the interface. So dependency injection has implementations provided through the constructor of the class. The service locator typically is a singleton registry. So you just have a class called bobspileofcrap.cs, and you call that thing and say, give me one of these. It's got a method on there that returns one. And it manages all the life cycle and all that other stuff. And this works great for a while until stuff starts getting really complex and you have a lot of dependency chains in the complex objects that you're building up. And at that point, you start running into problems because you don't manage life cycles and stuff like that correctly. And you get memory leaks and all that kind of stuff.
This pattern requires a class to call the service registry when it needs an implementation of another class. Now, while the service locator does reduce the dependency, being a singleton, it makes it easy to create breaking changes in an interface implementation.
So let's get into some examples. So an example of a non-DI app. The app needs a class that we'll call first, and this would be something like a controller. The app, creates that and then calls first. First needs second, which could be another service. So first spins that up and then calls it. Second needs third, which is, maybe a repository. It spins that up. It calls it.
Now, for a good visual of this, check out the show notes. There's a really great link. It's actually about PHP, but there's a really great link where I got the idea for this from, and it kind of draws it out, just the way it's written, and you can see how each level creates the next level really well. An example of a dependency injection application would be the app needs a class called first, which needs second, which needs third. So we know this already. The app creates third. The app then creates second and passes third into it when it creates it. Then the app creates first and gives it second, which contains third. So now first calls second, and second does its thing.
Right, which is probably calling third.
Yeah.
But first doesn't have to know anything about that.
No, it doesn't. Let's say you want to test how first handles a specific response from second. Not testing second, just how first reacts to it. And you don't want to test third at all. Using mocks to test can allow you to control what is passed and test at each level specifically. So you're only testing the code in first or second or third.
Right. And this is super duper valuable when you have something like a repository that's directly calling a database or it's calling, some interface to a database. You may just want to go, hey, look, I don't want this round trip in the mix. Let me mock this thing and see how the service talks to the repository without the database in there, because it speeds up your tests.
Also, if you ever have to talk to any outside services or outside APIs, this is great because you don't have to go call that service or API or whatever. You can just mock that and go, all right, I know what I'm passing in. I know what I'm getting back. Let me test that my code is doing what it's supposed to do.
Yeah, and this can let you test stuff like, okay, their service is offline right now. Like they're getting DDoSed. How does my app break when that happens?
That's
stuff
a
that you
great
can't
point.
prove. There's no way to do that in a real scenario, or they're rate limiting you. So if you hit their API, you're paying for that. Mm-hmm. You obviously don't want to be running the test suite 500 times a day.
That is so true. That is so true. So there's a few basic types of dependency injection that we're going to talk about, and your various frameworks use these in different ways. The first one, and probably one of the most common, is constructor injection. And that passes the dependencies into the client using the class constructor when it's creating the client. Like I said, this is the most common form of dependency injection. And dependencies are typically passed in as arguments for the constructor when creating the class. This is actually a specialized form of method injection that treats the constructor like a method that returns the class.
Yeah, which is actually a lot more true than you usually think about when you're writing object-oriented programs. Like, I just remember the first time that I thought about that, I was like, that's kind of a head fake. Because that is what a constructor does, is it creates a thing and gives it to you, but the calling semantics don't look like that.
No, they don't. And, well, what's really kind of helped me understand this is
JavaScript.
No, is the .NET Core app that I'm working on, because all the other stuff I've done has been either following along a tutorial or from a template, but there was no template. When I started, there was just a program.cs. I had to create my own startup.cs and everything, like from scratch on this. And I had to go in and I'm like, all right, well, how do I pass this in? How does this work? What do I need to do? And look things up and really just get in there. And that's where this really sunk in. I'm like, oh, it's creating that and then passing that. Yeah. So I totally get it now.
it clicked for me really big time with JavaScript modules, because you go in there and you have a function you're calling and you build this object up and then you return it. Mm-hmm. And so that's where that really started making sense for me, was when I started looking at the innards of how like require.js does stuff. Mm-hmm.
So since this is a specialized form of method injection, let's talk about that next. This passes dependencies in as arguments of a method. Sound familiar?
Yeah. And dependencies are treated as arguments passed in, right? So you can actually do stuff like you call a method and you say, hey, dependency injector, make me one of this thing, and chuck it in there, right? Like that's a legitimate workflow a lot of times when you don't have that as a dependency on the class for some reason. You need a new one, just new it up real quick.
Mm-hmm. Property injection stores dependencies in properties of the instance after the class is constructed.
So this would be like setter injection, right? Like you've got a property out there that's got a getter and a setter. What you're doing is you mark that somehow and say, hey, when this thing is spun up by the dependency injection framework, cram one of these in here.
a lot of times this is used for optional dependencies that aren't required, or they may have set defaults in the client. So it may be something that you pass in the necessary dependencies and have defaults, and you can use a setter injection to inject the optional dependencies or the ones if you don't want to use the default.
Yeah, I haven't done a ton of this.
I haven't
There's
seen
been
a lot of
few
it
weird. I've done it on web forms. That's the main thing, because you don't have access to the constructor.
Mhm.
Like I can't say, oh, make this constructor take 2 parameters. It has to be an empty constructor or the designer breaks.
Yeah, okay.
And so you have to do this way. Like you don't see that a lot, because it's one of those things that once we realized we could do this and that we should, do dependency injection by way of the constructor, frameworks got away from it.
Mm-hmm. Yeah, I mean, I've seen a couple of older things where you create it and then you call and you set everything. But not much of that.
Interface injection has the dependency provide an injector method that will inject the dependency into a client when passed into it. And this gets a little weird. For this to work, the client must have an interface with an exposed or public setter that accepts the dependency. It's used to tell the injector how to talk to the client.
Yeah, it's sort of a specialized form of like the setter injection. It was really interesting. When I read about this, I was like, you know what, I'm going to put it in the episode just because it's so unique.
Yeah, so I guess this is kind of where you have yet another abstraction in that setter.
Mm-hmm.
And, so you might even inject like a factory.
Yeah.
In this type. Like I've seen that a few times.
Mm-hmm.
I don't do that because developers get lost.
Yeah. Now, there's a couple of other types of frameworks that are around for injecting dependencies. Some testing frameworks are not requiring clients to actively accept injection, which makes testing legacy code possible. And we kind of talked about that a little bit earlier. This is something that we want to do a deeper dive into at some point, where we talk about how to add testing and some other things into your legacy code.
Yeah, and in languages like Java, it's possible to use reflection to get at private attributes, which you can also do in .NET,
Mm-hmm.
by the way. And that makes it public when testing. So sometimes you can sort of do setter injection when you really shouldn't be able to.
Yeah.
That can be handy. Some inversion and control implementations completely replace dependencies instead of removing them. So they'll basically spoof one and cram it in there, and it doesn't really do anything.
Mm-hmm. So now we're going to get into some of the advantages of using a dependency injection framework. Now, the one that I'm most familiar with is the .NET Core, because that's the only one I've really used. I've done a little bit of sort of pseudo dependency injection, but we didn't have that set up when I started. And so this is like kind of my first foray into it. Have you used any other frameworks?
Yeah, structure map, Ninject, Require.js, Lamar. Is it Lamar? It's the one that Jeremy Miller built. I think it was Jeremy Miller that built that. It's a sequel to structure map. Let's see. There's been 3 or 4 others. I mean, I've used a bunch of different ones and used them in a variety of circumstances. So JavaScript, Ruby, C#, obviously.
Mm-hmm.
Yeah, I've used a bunch of that kind of stuff.
I've done a little bit of Ninject in some of the tutorials I went through when I first started working with MVC, but I haven't really done a whole lot of an actual framework. I've just sort of not written my own, but done some pseudo DI work trying to get things set up for it.
Yeah, and I mean, I've also taken a service locator pattern and moved that to a framework, which is when you start getting a complex, big app and you have to do that, like that
sounds complicated.
Yeah, it gets gnarly really fast.
So some of the advantages. First off, it makes testing individual units of code easier. We've kind of hinted at this already. Clients become more independent because the code is written in testable chunks. It allows for mocks of the dependencies to be created as well.
Yeah, and this also makes it where clients can be a lot more configurable.
Mm-hmm.
So clients can use anything that supports the interface the client expects. So you could have a situation where you've got an object that tells you how to talk to a web service that gets data in and out.
Yeah.
But you could have a config setting that says, hey, when this setting is here, change this type that gets passed in, and it talks to this other service instead.
Mm-hmm. Yeah, so long as they both implement the interface,
Yeah.
then you're good.
You just make an adapter essentially for each of them. And then it's a really easy way to get a plug-in model without you having to do reflection.
Yeah. And the only thing that is really fixed is the behavior of the client at that point.
Yeah.
And all the implementation details are hidden and not affected by any changes behind the scenes of that interface. So if, for example, you do have to change out who you're talking to, or if you need to go in and fix some bugs, you don't have to change multiple areas of code. You go into that one place and change it and leave the interface and the client alone.
This also helps a lot as far as getting rid of boilerplate code. So boilerplate code is parts of code that are reused multiple times but can't be abstracted out. And basically what you do is you roll this into a dependency and then the injector injects that.
One thing I think about is before using a DI framework, I would create multiple constructors. And now you can call in .NET, you can use this to call the constructor. So what I would do is I'd be like, all right, well, let's say I need 3 services from, in what I'm doing. Well, I may not have any of those services, so I have to call a new up. I may have 1 or 2 of them. So I'd create a constructor for, all right, I've got this service, but not the others. And it would just I would tier them so that eventually it would call, using reflection, it would call itself until it had all the services it needed, and then call the one that took in all of them.
Yeah, but constructor chaining like that, when you start getting 3 or 4 different requirements and trying to figure out which 2
yes, I know.
That's present.
That's what I'm saying. Like,
it's ugly.
I would do that, and oh man, I mean, it's not really boilerplate code, but it's just something that you don't have to do when you're injecting those dependencies.
Yeah, or opening a database connection. You got to create your object, and you got to open the connection, and then you can do something with it. It's like, no, just pass the connection in. It's assumed to be initialized.
Yeah,
and I can keep that for the length of the whole request, so I have reasonable transaction boundaries that correspond to the unit of work in the app.
That's one of the things I like about ORMs is they kind of handle that for you. The only problem is when you have caching, and I've run into this issue where it will cache it and it'll be like, all right, well, at the end of the request, I'll send it all off. And I'm like, yeah, but I need you to put this data in the database so that I can then call. We were talking earlier to Josh on Facebook about SSRS. So then I can call SSRS to get the report that contains that data in it. So you have to close that connection or commit that connection and then reopen it so something else could use it. Oh, I've got there's some complications in there, and I've tried to make them as...
Yeah, you sound like you're about to have a threading problem.
Yeah, well, I've solved that issue. I put the complexity down at the repository level, so that it closes and reopens it. And so nothing above that cares. It calls it calls that, it forces the commit, it pushes it out, and then it reopens so that the next thing that needs to call it, it's there.
Are your transactions scoped? Are your connections scoped transient, or are they scoped to the request?
Scope transient.
So you could just new up, or not new up, but you could just call the dependency injection framework and go, give me another connection.
Right. Yes.
Right there. I got you.
Yeah. So that makes it easier. There was a little bit of complexity with it, but it wasn't terrible. It was just like I hit the point where the ORM, the rare point where the ORM is no longer helpful but hurtful. Like I've hit the point where it's no longer helpful and I have to do things myself. But this is the first time I hit that it was hurtful, and it was a while back, but it's still stuck with me. That's the thing. This was months and months ago, but it's still
it makes an impression.
It does. It really does. The other thing, going back to the advantages of a DI framework, is that dependency injection doesn't require changes to the behavior of the code. That means that it can be applied to legacy code.
Yeah, this makes it where you can actually test things, and you can test the interaction between new code and old code in a way that you probably couldn't do before. So this lets you start choking out the old code and choking out the untested code. You've got a way to do that now.
Also, it allows for multiple developers working on the same code at the same time.
Yeah, and I'm doing this at work right now. The other senior dev, or the the senior dev. I keep forgetting that I'm not a senior dev anymore. I'm an architect. He's doing the front end.
Yeah.
And he's making API calls to a back-end API that I wrote. Well, I don't have that API yet. So what I did is I made service classes that do RESTful calls to it. And I gave him the interfaces. And so he can mock those and he can work on stuff and fake until such time as those things are implemented. And then he gets it in a NuGet update. Like, that is super duper handy because now we can go in parallel and I'm not on the critical path necessarily on this project.
Nice. That's really cool. Now, with this, classes can use each other because they only need to know the interface. Like you said, you can mock stuff up for him while you're working on it. And honestly, I should start doing that. The next big project I work on, I could do that. I could do that, and the UI developer could be working on things much quicker.
Yeah.
Just testing their code if they get done first. Huh.
Yeah, it's not so much the speed improvement as it is I'm not at fault when things are behind.
Well, I'm just thinking of, all right, because right now I'm working with Dave, who's junior developer, Junior Developer Toolbox host, if you guys listen to that show. But before that, I was working with our lead UI developer, who was a lot faster. No offense, like nothing against Dave. He is really great for his level, but this is a guy that's been doing a lot longer and could crank stuff out, and he'd just be sitting there waiting on me.
Yeah.
And so I had not thought about doing that. Man, that's a great idea. I'm going to start doing that. That's cool. That's really cool.
So now that we've talked about all the advantages in completely glowing terms, let's go through some disadvantages, because there are some.
Yeah, we have really been focusing on all the good things about DI, but we do need to be realistic here.
So would we call this section the DIY?
Yes. I love it. The DIY.
Yeah. So let's talk about some disadvantages. The first one is what it does to code readability. It can make things a little bit more difficult, especially if you don't have a good IDE. So like if you're using Vim to do everything, I've done DI in Ruby with Vim.
Yeah.
And that was not my favorite life experience. Now you do it a little differently there, but even so, it's just not, because they have the whole duck typing thing and all that, but it can get a little nasty.
Yeah, the behavior is separated from construction.
Right. So if you're really dependent on the parameters that are coming in and you need to know what those are, you're going to have to like hover over stuff and look at it because you can't see in the flow what's happening.
But also increases the number of references in a system. So it's really, really nice. And like I said, I've kind of done my own little pseudo DI in stuff, but it's really nice to be able to look at something in Visual Studio and click the references and see all the places that reference it. One of the things that I don't have set up in Visual Studio Code, so when I hop over and help out on the front end, I'm like, all right, well, where all is using this? Not to think and look through stuff, and because we're doing Angular components, and so there's like one component may be used multiple places.
Yeah, that gets really, really irritating quickly. The other thing that's irritating is you go to source, but it's now the source of the interface, not the source of the implementation, which is probably what you wanted.
Yeah.
That can be a little annoying too. Other thing that tends to happen a lot is frameworks tend to be implemented with reflection or with some kind of dynamic programming. So or both.
Yeah.
So it might sit there and go, okay, let me look at this object, figure out how I've got to construct it, runtime generate code that runs the thing, and then compile that on the fly. So you have startup costs that get in the mix. It can also make it a lot more difficult to use your IDE to find all the references, all the places stuff gets used, because some of that code is not present.
Yeah, because it's not being created. It's created in the DI framework and then passed in.
Yeah. And it gets even weirder because you got stuff like if you change something, like you change one of the implementers and you go, I've got to throw this file not found exception in this one case, right? Guess what? You really change the interface signature without changing the interface signature.
Yeah.
Right? Because now whatever the caller is has to expect that, or it will throw it. And so you may have that thing bubble up 4 or 5 layers and you're like, well, what is this? Where does this come from? I don't know.
So like what we're hinting at here really is the next one, which is dependency injection massively increases the complexity of your code.
Yeah, of the full set of code. Like it shrinks the complexity of a piece, but the sum of all of it is bigger.
Right. More work is required upfront. And this is what we were complaining about .NET Core earlier, to set up the dependencies and inject them instead of just creating what you need to call at the time that it's needed.
Yeah, the other thing is that errors don't get caught by liners and compilers necessarily because they now show up at runtime. This would be like not necessarily signature changes, but there's just some weird stuff that happens at the edges of language that you can't set constraints around as easily when stuff is spun up dynamically.
Oh, yeah.
And it can move the complexity, is no longer in the classes, it's between them.
And finally, it creates a dependency on dependency injection frameworks.
Right. And so the fix to that is you get a different dependency injection framework and use it to spin up the first one. Right? Like it's just turtles all the way down, man.
Right.
That's how you fix this.
Once you've started, you have to use the framework. Now, that said, I built this small service that like I said, I was doing sort of pseudo dependency injection. Basically, I had created a constructor that you could either pass in the repository or would create a new one. It defaulted. Well, I created it. It went out. Another dev came in and did some work on it and needed some stuff. So instead of adding that to the repository that I'd created or extending that repository, creating a new one and inheriting from it, she just created a new repository and just spun it up in the method. It was like, all right, well, I can't test this anymore. Like it completely ruined all the testability, the reasons that I had done that was so that we could unit test and we could mock up things, but I could no longer do that because it was going to call that repository.
Yeah, and it's really ugly when this happens, right? Because the developers that are more competent, that are doing things correctly, are going to be a little bit slower, especially initially. And the people that are not doing things correctly look like they're faster and they get rewarded.
Yes. Until
they get caught.
Well, I would say they only get caught if you have someone that knows what to look for. What happens is 6-8 months later, something needs to be updated, it needs to be changed, or it stops working and someone else has to go in and fix it. That's what I've seen. So like these are sort of the downsides to using a DI framework. Guys, this has been a bit of a deep dive into dependency injection specifically. This doesn't go into platform or language specifics, though Will and I, as both being .NET developers, did talk a lot about that based on our experience. It's up to you to now go out and find out more about the languages and platforms that you work in. Just about any object-oriented language will have a way to apply dependency injection. Most of the more common ones will even have pre-built frameworks that you can use. The information that we've provided in this episode can help you in determining if you need one and help you when determining which one to use in your code. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to point out that anytime that you apply a best practice, you have to start thinking about the downstream effects, specifically with the team dynamics. This stuff looks really abstract until you have a team member that doesn't do what they're supposed to do. What are the incentive structures around that? Do they get caught? Do you have anything set up to catch it? Because, even if you're bringing in best practices and everybody on the team is on board, they're still going to screw up. You have to have ways of enforcing this. Like all these things are nice abstractions, but if you can't catch it at the point of the mistake, you're not going to win. You're going to be constantly fighting this. So you got to think about that when you're implementing patterns. And that's pretty much all I've got. Just think about the other people.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.